As you know, I'm Kainton the Tech Pro, and today I'm going to teach you how to perform hierarchical clustering in Python using Jupyter Notebook. So this is the diagram you get when you create a hierarchical cluster, and this is called a dendrogram. And then this is the plots where the clustering has been performed at this point. So I'm going to take this out so that we can start right from the scratch to perform hierarchical clustering. So let me start a new Jupyter Notebook. So I'm going to go to File, New, Python 3, and I'm going to import. First, I'm going to import numpy as np, and I'm going to, of course, import matplotlib. Import matplotlib.pyplots as plt. And then I'm also going to import make blobs. And make blobs is imported from sklearn.dataset. So basically, is you use it to create data sets that you can use to perform clustering or cluster analysis. So from sklearn.datasets, import make blobs. All right. So I'm going to run it just to make sure everything is fine. Matplotlib.pyplot import matplotlib.pyplot as plt. There is no module named matplotlib. Import matplotlib.pyplot. Oh, pyplots. Sometimes these typos can be a problem. So I have matplotlib.pyplot. All right. So let's just create a set of 200 data points that we are going to use for clustering. Meanwhile, let me add comments just to clarify what we are writing. So let me just say, do the necessary imports. And here I'm going to create a blob of 200 data points. Okay, so let's create this 200 data point and then we proceed from there. So let's call it data sets is equal to make. So this is syntax, make the blobs, and you specify number of data points you want. So in this case, we want the number of samples to be 200, and we want it to be just two-dimensional data. Let's keep it simple. So let's have two-dimensional data. So number of pictures is equal to 2. In this way, we can have, okay, because we don't need three-dimensional data in this case. So then we have to choose the number of clusters we want. So I'm going to say centers equal to 4. And then I need to just specify that the standard deviation of these data points is cluster std is equal to, I can choose any number between, let's say, 1 and 2. So 1.6, and then random states, you have to include this, is equal to 50. All right, so I've created 200 data points. All right, so now these data points actually is made up of two parts, data set 0 and data set 1. So if you view data set at this point, you'll see that it's made up of data set 0 and data set 1. So this data set 0, the 200 data points, and we also have data set 1, which is kind of the clusters from 0 they belong, but we are not interested in this one. All right, so I'm going to just extract data set 1. So let me just call it points. Points is equal to data set 0. So let's just take the data set, not really the clusters. All right. So at this point, we want to now perform hierarchical clustering. So to perform hierarchical clustering, you can import this is import skipy.cluster.hierarchy. So the hierarchy is a submodule in scpy.cluster, and you have to use it. So import scpy.cluster.hierarchy as SCH. Let's call it as SCH. We also have to import agglomerative clustering. So from sklearn.cluster import agglomerative clustering. So agglomerative clustering is simply another name for hierarchical clustering. So I like to run it each time to make sure there is no error. All right, so at this point, we want to now create a dendrogram. Of course, you know that when you are performing hierarchical clustering, the key thing you want to generate is a dendrogram, because you want to start with everything in the same cluster, in individual clusters, and you add the ones that are close together until you get everything in one big cluster. So let's create a dendrogram. Dendrogram is equal to SCH. So this SCH, which is this object we imported, dot dendrogram. So you use the function dendrogram and specify the linkage. You specify the linkage as parameter to the dendrogram function. Linkage. And the linkage now takes the data sets. So the data set in this case is points. And the methods could either be forward linkage or forward or backward linkage. So in that way, it's called WARD, W-A-R-D, okay? So at this point, I'm going to just put a comment here that says, create a dendrogram. All right, so this is what I have. Let's try to run it to see if everything is fine. Yeah, so we have this dendrogram, but I would like to show the plots of this data just to kind of see how this data looks like in a scatter plot. So I'm going to just I'm going to just display, because I don't want to keep typing this. So I'm going to just, let me take out this. So let me just do a scatter plot of these data sets. So it's actually data sets. I'm going to do a scatter plot just to see how the data looks like when you run. So this is how the data looks like, and we created a dendrogram at this point. Now we want to see the clustering, actually where the clusters are. So we want to put the centroids, if you will, the centroid at the center point of each cluster. We want to specify it right there. All right, so how do we do this? It happens that you can do it first. Let's assign each of the items to clusters. So I'm going to say YHC. This is just a variable. So this variable is kind of creating a data set that has the cluster where each data point belongs is attached to that data point. So you have 2.1, 2.2, then it belongs to cluster 1, and so on. So we have at this point 4 clusters: cluster 0, cluster 1, cluster 2, cluster 3. So all right, so we say the first thing is we build the dendrogram, we check the scatter plot, but we actually need to perform the actual clustering. So let me just say perform. I'll recommend you do this a couple of times so that you get used to it. Perform the actual clustering. So let's call it hierarchical clustering. That's just the name of the variable. Agglomerative clustering. Yeah, so there is a function, and give it number of clusters you want. N clusters equals, this time we want 4 clusters. And how do you measure the distance between the data points? You can actually use different methods, maybe a Manhattan distance, Euclidean distance, Mahalanobis, and so on. But this time, let's use the common one. Affinity specifies the distance methods or metric you want to use. So yeah, let's use Euclidean. Okay, and finally, you use the same linkage, which is word. All right. So hopefully everything should be fine. All right, so this HT now performs the clustering. Now, after performing the clustering, we now have to fit the data set using this HT. So we are actually going to assign each of these data points to clusters. So to do that, I'm going to just create a new data set called YHC equal to HC.fit. So we are fitting the data set and HC.fit and predict which clusters the data points belong, and I'm going to say points. All right, so at this point we have performed the clustering and we have the data points, each of them belongs to one cluster or the other. All right, so let's now visualize how it looks like. So I'm going to say plt.scatter points, where points YHC is equal to 0, 0. Okay, YHC is equal to 0, 0, and points against YHC is equal to 0, 1. So this is cluster 1. Cluster 1, for all the data points in cluster 1, that is what we are trying to plot. Let's say size S is equal to 100 and color is equal to cyan. All right, so I'm going to plot this, and so it says invalid syntax. Where is it coming from? So we have points as well at this point, points. So run. YHC is equal to, we are checking where it is 0.1, and if I run it, I should have only one cluster. So let me just plot a second cluster at this point. So this is 0, 0 and 0, 1. This is 1, 0 and 1, 1. 1, 0 and 1, 1, the second cluster, and the color, let's give it blue or yellow. Okay, so I'm going to run it, and we have two clusters at this point. Now, instead of just typing it, I'm going to just copy it and paste. So we have, this should be 2, 0 and 2, 1, and this should be 3, 0. This is 3, 1. This is 2, and this is 3. Okay, let's give this a color of red and this a color of green. I'm going to run everything now. Now we have the clustering has been performed. Now let's try to plot. Let's try to plot, to put in the centroid in between. As in, we want to put in the centroid at this point. So plt.scatter. So the centroid should be, so we have, let's see. Let's see, centers. So the centers of these plots, you need to extract it. So the centers is k-means of clusters. Sorry, not k-means of clusters. Is hc dot clusters dot centers. I think that should be. Let me just check. Or maybe I don't think, maybe this is not necessary, but I'll just check because I'm trying to confuse, I'm kind of confusing k-means and hierarchical clustering. At this point, we don't need to go any further. So we actually perform hierarchical clustering at this point, and we have our dendrograms designed for us as well. So I recommend you take some time to go through it, try to do it yourself to get your head around it. And if you have any questions, feel free to leave for me below in the comment box below. If this has been informative for you, please subscribe to my channel, and we'll see you in the next lesson.